Okay. So we heard this morning that 11% of ASD cases have a known genetic etiology. And because of that, I believe that every child with autism should undergo genetic testing, or I must be more precise, every child with autism and intellectual disability. And this should include karyotype, where you can see, for example, Down syndrome, PCR for detecting Fragile X syndrome, a chromosomal macroarray, or as we call it, CHIP, to detect Cnvs, which means microdeletions and microduplications, and whole exome sequencing for detecting point mutations. Now, the common Cnvs that are associated with autism are circled here. For example, the 15q11 deletion, when the deletion comes from the mother, and the 16p deletion, and 22q deletion, the syndrome that I'm working on, also named DiGeorge. Now, this is the excellent paper that came out in Cell, and we just heard the talk of Joseph Buchsbaum. And what I want to emphasize in this slide, that out of the 102 disruptive de novo mutation in ASD, about half of them, 49 genes, are common to ASD and intellectual disability, which means that if you take a cohort of individuals with intellectual disability, half of the genes that you find that are mutated are the same genes that are mutated and causing autism. Now, I think this is an interesting slide. What you can see here is the most common studied syndromes. So they took all the studies that looked at specific syndromes, and in these studies they evaluated the prevalence or the rates of autism. And I divided these studies to the one that I circled with the highest rate of autism. It says here 60%, and this is Rett syndrome. And it's highest because it has the lowest IQ. In the triangles, you can see Fragile X syndrome, you can see tuberous sclerosis, Cornelia de Lange, and Engelmann syndrome, which has a little bit higher IQ, but in the middle. And those with the highest IQ, which is the 22q, actually Down is not so good example, but neurofibromatosis type 1 and Williams, they have the lowest rates of autism. So you can see from this slide that there is a direct relation between IQ level and the rates of autism. Highest rates of autism in those syndromes with lowest IQ. So why ASD is more common in neurogenetic syndromes? I'm going to suggest two options. One, that these are behavioral phenotypes, and the other that it's merely an epiphenomenon of intellectual disability. So what are the behavioral phenotypes? This is example I give in every lecture. Williams syndrome, microdeletion in chromosome 7. And we have a family day with Ninette, a singer. They all go on stage and sing and dance with Ninette because they have strong social appetite. On the other hand, we do it together, Williams and 22q, because I coordinate the treatment of both syndromes. Almost no child or adult with 22q will go on stage because they have microdeletion in chromosome 22, which makes them shy with high social anxiety. And now going to the definition. What is the definition of behavioral phenotype by Elizabeth Dykens? the definition is that it is increased probability that person with a genetic syndrome will show certain behaviors relative to, and this is what most important, relatively to matched IQ person. So, for example, what are common behavioral phenotypes? Williams syndrome and the staring behavior, they like to stare at people, or the social appetite, Fragile X and gaze aversion, 22q and schizophrenia-like psychosis, and Prader-Willi syndrome and excessive eating. All these are common in individuals with intellectual disability, but in these syndromes, these behaviors are far more common. What about ADHD? ADHD is not a behavioral phenotype. Why? Because it's very common in all syndrome. It's a non-specific pathway of any brain insult. So, what about ASD? The rates that we saw seems to be high and correlates with the degree of intellectual disability. So I'm not sure that autism really fulfills the criteria for a behavioral phenotype. Now, why 20 years ago ASD, the rate was of intellectual disability in ASD 20 years ago when I started my residency was 70%, and today it's only 30%. This is a wonderful figure that explains. It is actually a substitution in diagnosis. What does this slide show? It is taken from the US. It is based on the number of children in US that are eligible for special education. And what you can see is that parallel to the decrease in the rates of, parallel to the increase of the rates of ASD, there is a decrease in the rates of intellectual disability. So it means that we really don't have increase in autism, we just have diagnosis substitution. What do we find when we do genetic screening in ASD? We can see that it's mainly effective for ASD plus intellectual disability, because lower IQ and adaptive functioning ASD individual with a genetic mutation, we heard about it this morning from Joseph, rate of genetic mutation associated with ASD is linearly correlated with the degree of intellectual disability, and therefore there is no use to do screening, or less use to do screening for autism with a normal IQ, because the yield will be very low. That's why in Israel, you may know that during the last 2 years, it's part of the health basket to have genetic testing for autism, but only if you have intellectual disability. If you have autism with intellectual disability, you are entitled for CHIT, for chromosomal microarray, and for whole exome sequencing, which is, and when we do the whole exome sequencing, we do it also to the parents, which actually cost to the taxpayer of Israel 12,000 shekels per patient. Now I'm going to talk something that I think is very important about the differential diagnosis, the clinical differential diagnosis between ASD and ID. And I want to remind you that we have the E criteria in the DSM-5 for autism saying to make comorbid diagnosis of ASD and the intellectual disability, social communication should be below the expected for general development level. Now, it's easy to say than to do, because I can attest as a child psychiatrist. Most child psychiatrists are not comfortable with intellectual disability. They really do not know what is the atypical behavior of a child with mild intellectual disability, moderate intellectual disability, severe intellectual disability. but they are much more familiar with autism. So when they see a child with intellectual disability, they don't know the norm for social behavior in a child with intellectual disability, but they know autism, so they tend to call a child, to diagnose a child with intellectual disability as having autism, because that's what they know better. Now, I read this excellent paper in Frontiers, 10 minutes? Okay. I read this excellent paper in Frontiers of Psychiatry. I highly recommend this paper to everybody. And what they say in this paper, the group of Katie Lord and Bishop, that we should distinguish between basic social skills and advanced social skills. And the basic social skills, these are the skills that can help you distinguish between autism and between ASD and intellectual disability. Because in children with intellectual disability, the basic skills are relatively intact. So they know how to make eye contact. Their facial expressions is quite intact. The gestures are good. They have capacity to share enjoyment and to participate in simple back and forth games like peekaboo. Whereas young child with ASD is impaired in these functions. The problem that these signs don't help you much when the child go older, because children with ASD, as they go older, they acquire some of these skills. But what about the advanced skills? The conversation skills, peer relations, ability to modify behavior to match social expectation, and social inhibition. All these are impaired both in children with intellectual disability and autism. That's why we as child psychiatrists misdiagnose intellectual disabilities as autism, because the advanced social skills are impaired also in children with intellectual disability. We have another problem with diagnosing ASD into intellectual disability. Some of the skills strongly correlate with IQ, like the CARS and the aberrant behavior checklist. The SRS norm, the social responsiveness scale, as they declare in the manual, are for children with IQ above 70. Non-verbal children are not scored on 25% of the ADIR items. And we know that there are false positive scores on the ADOS for non-verbal older children. This is also, the tools are also reasons for false positive identification of autism in children that have only intellectual disability. This is a study we conducted in Israel with children with 22q deletion, age 4 to 8, and we found that 16% of them have ASD. It was together with Yafa, he is the first author here at the audience, and together with Corey Schulman. And we see that also preschoolers with 22q have high rates of anxiety disorders and ADHD. And when we look at the severity of ASD in 22q based on ADOS, there is a way to make the ADOS scores to reflect severity. We find that, and we compare them to children the same age with idiopathic autism from our preschool program that is headed by Dolly Sobol. We find that, sorry, there is a mistake here. The idiopathic ASD have higher overall scores. Those with the syndrome, the severity of autism is less severe. Besides one field, which is the restrictive and repetitive behaviors, where 22q and autism have the same severity. And I think this is like in all syndromes. In Fragile X syndrome also, the degree, when you take a group of Fragile X kids and you look for the and you identify those with autism and you look for the severity, they are less severe than those with idiopathic autism, besides on the repetitive and restrictive behavior domain. And I think part of it is when, for example, when I treat 22q, I treat the referral source are physicians. They come for the cardiac anomaly, they come for the cleft issues, because we coordinate also all the medical treatment. But when when we find autism, it's many times incidental, because it wasn't like when you come to diagnose idiopathic autism, you come because of the symptoms of autism. Now, another reason for false positive identification of autism in children with neurogenetic syndromes are the medical comorbidities. Because when you have motor deficits, how can you do gestures? So you may think that they don't do gestures because they have autism, but actually it's motor deficits like CP, etc. When you have hearing and visual impairments, also you will have delayed speech, you have a different behavior. We as child psychiatrists that are experienced more with the high IQ autism, and we are not familiar with hearing, with deafness, or visual impairments, we might be mistaken. Or the hypernasal speech in 22q, which is sometimes incomprehensible, is also a dilemma for diagnosis. So what they recommend in the literature, that when, let's say I'm a child psychiatrist, I'm not familiar with hearing impairments, I should consult to take together with me into the evaluation room someone that is familiar with language clinician, exactly. Okay. To conclude, I believe that the increased rates of ASD in neurogenetic syndromes is not solely, but mainly an epiphenomenon of intellectual disability. The rates of ASD strongly correlates with the degree of intellectual disability. The increase in the diagnosis of ASD is paralleled by this decrease in comorbid intellectual disability and in rates of intellectual disability. There is false positive OSD diagnosis when the effects of ID level and comorbid medical condition are not taken into account. Differential diagnosis between ID versus ID plus ASD is complex and should rely on evaluation of basic social skills, which are relatively intact in ID and impaired in ASD. And I'm going to conclude that there are actually two types of ASD. One with normal IQ ISD and one ASD in intellectual disability. So what are the differences? These are totally distinct diseases, maybe two distinct diseases. The normal IQ, paradoxically, is familial because we have all these genes that we find in the GWAS with small effect. They run in the family, whereas paradoxically, the ASD, intellectual disability, is usually not inherited. These are the de novo mutations that you see only in the child and not in the parent. The ASD in normal IQ is less biological, whereas the ASD in ID is more biological. The male-female ratio in the normal IQ is 4:1. In those with ID is 1:1. And the yield of genetic screening for mutations is low in normal IQ and is high in the ASD ID. Now,